Hello everyone and welcome back to another tutorial video from Math 122. This is a video that I'm doing by request from one of the students who asked me to go over this type of problem, a problem where you're trying to identify graph transformations. And specifically, they asked me to look at problem number, I believe it's problem 19 from the practice problems for exam 1. And this problem looks like this. And down here, you'll notice that this was actually presented as a multiple choice problem. And we can actually already see that the correct answer is going to be this one down here. But I want to explain why and how we can get there. So the question is basically asking you to try to look at a graph and figure out what the equation might have been by basically identifying what type of graph transformation was used to get there. And whenever you're asked to do something like this, again, as usual, I always suggest tackling problems in a consistent series of steps so that you don't get lost or confused. And the first step is to try to identify the shape. Now, this obviously requires you to be able to remember roughly what at least the more important functions we've gone over in this class look like, what their graphs look like. And looking at this, you notice that this is a function here that has what appears to be like a vertical asymptote along this line right here. And this looks like it's just going to keep going upwards like this. And the question then becomes, is there a function that we know of from this class that we've gone over that has a shape that looks a little bit like this, that has an asymptote, a vertical asymptote like this? And then most importantly, we'll notice that there's no values defined for this function on the left-hand side of this asymptote over here. So it only starts to exist after this vertical asymptote, and then it keeps on going, we can presume, roughly forever. So here we notice a vertical asymptote. We notice that it's only defined on one side. Of the asymptote. In this case, it's on the right side. And your suspicion should be, if you weren't already thinking this from just the general shape of this function, that this is probably the function natural log in some form, but that has been shifted or otherwise transformed. Okay, so we figured out that the function we started off with, our baseline function as it were, was probably just ln of x. So step 2 now is to identify the transformation. And specifically, you should ask yourself, are there any shifts, any flipping or stretching, etc.? And what are we looking for in this case? Well, we notice here, again, going back to our this vertical asymptote that we noticed that in this case, this is at about what, negative x equals negative 1/2 is this point here. So our vertical asymptote is over here, but for ln of x, usually the vertical asymptote is exactly at 0. So we notice that our asymptote is at -1/2 instead of 0. And that means that it has been shifted left by a value of 1/2. And we saw in class that left shift is adding inside parentheses. So step 3 now is just to assemble all these pieces of information. So the way that you do this is we have ln of x, but it's been shifted left by 1/2. And this means that we will have, or we have, let's say y equals ln of x. So we started off with ln of x. To shift it left by 1/2, we have to take f of x plus 1/2. And this is going to be ln of x plus 1/2. And you'll note that that's exactly what they have over here. So to recap this process, and again, these are graphs that we're working with. So whenever you're working with graphs, things are going to be somewhat imprecise. It's never going to be exactly perfect. But this is roughly the process that you should look for, is first try to identify the shape. In this case, we have like a log type function. But I could have given you like a parabola, and you would have thought if it's a parabola, that's something like x squared. I could have given you a straight line. If it's a straight line, then you know that that's like a linear function. I could have given you like an exponential, which would have looked like this, and you would have seen the shape, and you would have thought to yourself, that's exponential. But in whatever it is, the first thing that you need to do is to try to see, is the shape of the graph, the general shape of it, something that you recognize? In this case, natural log. Once you've recognized like the general type of function it has to be, in this case, natural log again, ask yourself, how did they shift that away from like the default position of things? The default position of natural log looks exactly like this, but it starts off at 0 instead. So it looks like this, which means that in this situation, we've been shifted left by, well, in this case, we see it's like about 1/2. So then you move on to step 3. You know, we have ln of x. We've shifted left by 1/2. So that means you add inside the parentheses, and this function is probably ln of x plus 1/2.